moving on to the next question. It is given that gas in a cylinder piston device expands from state 1 to state 2. The expansion process is polytropic, that is PVN is equal to constant with N not equal to 1. Assuming the ideal gas behavior, the expression for the work done W by the system is given by. So in this question we have a gas which expands from state 1 to state 2 following a polytropic process given by PVN is equal to constant, and the gas is an ideal gas. So work done is given by delta W is equal to PdV. So if I have to find work done from state 1 to 2, then I need to simply integrate this equation 1 to 2 PdV. Now we have a polytropic process given by PVN is equal to constant. So for state 1, I can write P1 V1 N is equal to C. For state 2, I can write P2 V2 N is equal to C. Now if I rearrange this equation, I can write P is equal to C by Vn, and directly transferring this value to this P, I get 1W2 is equal to 1 to 2 C by Vn dV. Further solving it, I can take this C out and we are left with dV by V ki power n. Now integrating it, I get V ki power minus n plus 1 upon minus n plus 1 from process 1 to 2. Or I can write this equation as C into V2 minus n plus 1 minus of C into V1 minus n plus 1 upon minus n plus 1. So as per our convenience, I can write the value of C. For V2 I can write this value, and for V1 I can write this value. So writing the values, I can see that I can write P2 V2 power n into V2 minus n plus 1 minus of V1 ki power n into V1 ki power minus n plus 1 upon minus of n plus 1. So if we solve this two, I will be getting P2 V2 minus of P1 V1 upon minus n plus 1. So from the given option, I can see that option B is the correct answer. Moving on to the next question, it is given that the temperature of the working fluid in a real heat engine cycle changes during heat addition and heat rejection process. The maximum and minimum temperature of the cycle are Tmax and Tmin respectively. If eta C is the thermal efficiency of a Carnot engine operating between these temperature limits, then thermal efficiency eta of the real engine satisfy the relation. So it is given that there is a real heat engine which is working between Tmax and Tmin, and the efficiency of that engine is eta. Now if a Carnot engine is made to work between these two limits Tmax and Tmin, and the eta C is the efficiency of Carnot engine, so what is the relation between eta and eta C? So it is a very general rule that two engines operating between two temperature limits Th and TL, none of the engine can have an efficiency greater than Carnot efficiency. So if a real engine is working between these two temperatures having efficiency eta, and if a Carnot engine is made to work between these two temperatures having efficiency eta C, then eta can never be greater than eta C, and eta C will be always greater than eta. Hence from the given option B is correct. Now moving on to the next question. It is a 1.2 meter cube rigid vessel contains 8 kg of saturated liquid vapor mixture at 150 kilopascal. The specific enthalpy of this mixture is, it is also given at 150 kilopascal. The value of Vf, Vg, Hf, Hg. So in this question we have a rigid vessel containing 8 kg of saturated liquid vapor mixture. So they have already defined the condition of mixture that is in mixed state. So let us understand the concept. So if I draw the TS diagram, so we obtain a curve like this. So this point is a saturated liquid point and this curve is a saturated liquid curve. Similarly, this is a saturated vapor point and this point and this curve is a saturated vapor curve. Now the region between these two is the mixed region. So there is a factor known as X, that is quality of steam. At this point X is equal to 0 and at this point X is equal to 1, and in the mixed region X lies between 0 and 1. If I have to calculate any property in this region, in the mixed region, property such as specific volume, then it is given by Vf plus X into Vg minus of Vf. Now from this equation I can also see that at this point X is equal to 0. So if I put X is equal to 0, then the value of specific volume will be Vf, and at this point X is equal to 1. So if we solve this, then we will get Vg minus of Vf. This get cancelled, and at this point value of specific volume will be Vg. Now between these two regions it is given by Vf plus X into Vg minus of Vf. Now we already have Vf and Vg values. I have to find V, which can be calculated, which is specific volume. V is specific volume, and we already have, which is given by, and specific volume is given by volume by mass. So we already have the value of volume and mass, where V is 1.2 meter cube and M is 8 kg. So I can find V 1.2 by 8 is equal to 0.15 meter cube per kg. Now putting this value in this equation, I can find putting the value of Vf and Vg also, I can find the value of X as 0.1285. Similarly, I can calculate the value of H as Hf plus X into Hg minus of Hf. So we have Hf value as 467.13 plus 0.1285, Hg value as 2693.1 minus of 467.13. So I get the value of H as 753.35 kilojoule per kg. So this is NAT type question and you have to type the answer, and there are no negative marking for this question if you type wrong answer. The answer in the gate is given in the range, which is 750 to 755.